This is the AP Classroom, Unit 2, Free Response Question Set B, question number 2. For this problem, no calculator is allowed in this question. We're going to skip all of this basic information up here. Again, if you have not read this, please do so. Come back and join me when you are done reading that. I'd rather use this time to go ahead on to the problem. So we have the number of passengers who've boarded a ship is modeled by the differential function P, where T is the number of hours since boarding began. Values of P of T for selected values of T are given in the table above. So P of T is the number of passengers and T is hours since boarding began. According to the model, what's the average rate at which the passengers board the ship in passengers per hour over that time interval from 1 until 8? I'm going to squeeze some of this work in down here. For part A, average rate. So here's our average rate of change over this time interval from 1 to 8. So we want the number of passengers at time 8 minus passengers at time 1. Be careful, it's not the passengers at time 0, it's at time 1, divided by 8 minus 1. Passengers at time 8 is 728 minus passengers at time 1, 35, divided by 7, and there is no calculator on here. 728 minus 35, well, 728 minus 28 would be 700, and then I'll have to subtract 7 more, so 693. 693 over 7, and 693 divided by 7 is, 7 goes into 69, 9 times that's 63, remainder 6, so another 9, 99. If you can't do that arithmetic in your head, that's fine. You can go ahead and do the division and subtraction over on the side. That's fine. But here we are, 99 passengers per hour. Okay, part B. Write P prime at 4.5 as the limit of a difference quotient. Then, this is the second part, use the data in the table to approximate P prime at 4.5. Use the computations that lead to your answer. So, as a difference quotient, P prime at 4.5. There's two ways to write this, and either one would be acceptable. Difference quotient, so we're looking at a limit. Now, you could look at this as the limit as T approaches that 4.5, and this would be P of T minus P of 4.5 over T minus 4.5. That's one of them. Here's the limit as x approaches a, f of x minus f of a all over x minus a. Or the other one, you could say the limit as h approaches 0. This would be your function, so P of x plus h, so 4.5 plus an h, minus f of x, P of 4.5, all over h. Either one of those standard difference quotients is acceptable. That's the first part of question B. Now, the second part of question B says to use the data in the table to approximate P prime at 4.5. We don't have a 4.5, we don't have a 4.5 in here, but 4.5 would fit right in here. And it's exactly halfway in the middle between 3 and 6. So what we can do is we can actually find the average rate of change between 3 and 6, and that will be a good approximation for the instantaneous rate of change at 4.5, which is in the middle there. So P prime at 4.5 is approximately P of 6 minus P of 3 all over 6 minus 3. P of 6 is 600 minus P of 3. I know you can't see the table, but you have it in front of you. TO4 on your paper, right? Divided by 3. And 600 minus 200 will be 400 minus 4 more, 396 over 3, which is 132. There's the estimated instantaneous rate of change for time at 4.5. Okay, let me get another piece of paper here, and let's go on and do part C. Sorry about the shuffling here. Part C says, must there be a time t for t between 3 and 6 at which P of t is equal to 500. All right, so we're looking in between 3 and 6. In between 3 and 6, is there a time when there are 500 passengers? At time 3, there were 204 passengers on the boat, and at time 6, there were 600 passengers on the boat. So between those two times, does there have to be a time when there were exactly 500 passengers on the boat? And your gut feeling is saying yes, but now we need to explain it. All right, so part C here, yes. And we're going to say because of the intermediate value theorem. All right, and just explaining that out in words. P of t is differentiable. Up here they tell you it was differentiable, which means that it is continuous. P of t is differentiable. And therefore continuous. I can never remember if therefore has an E on the end or not. To me, it looks bad both ways. I think actually I've looked it up. I think it's acceptable either way. P of t is differentiable and therefore continuous on the interval between 3 and 6. P of 3 is equal to 204 and P of 6 is equal to 600. 500 is between 204 and 600. Therefore, there must be a value between time equals 3 and time equals 6 where P of t equals 500. Whew. And the last one here, D. Okay, the total number of gallons of water used by the passengers on the ship is modeled by the function G, defined by this mess, where T is the number of hours since boarding began. Find G prime of 4, which is the rate at which passengers use water in gallons per hour at time 4. Oh, sorry, I didn't realize I had that off the screen. I'm so sorry. Basically, again, given by the function G is here. G of t is 120t square root t, where t is between 0 and 8. We want to find G prime of 4. raise this up so we can write on here. All right, let's find the derivative. Now, I'm going to do some rearranging first before I do a derivative, since I have both powers of t here. So let me say g of t is 120t times the square root t, which is t to the half. Now, you could do product rule right here, but it actually might be easier if you rewrite this as 120t to the 3 halves. One exponent here plus a half is 3 halves. We still haven't done a derivative, so don't stop here. Find g prime now. Pull that 3 halves down. 3 halves, or 1 1/2 times 120 is 180. T to the, subtract 1 from the exponent, half. I'm going to go ahead and rewrite that back with square roots. And g prime of t is 180 square root t. We are asked to find g prime of 4, which is 180 square root 4, or 180 times 2, which is 360, and these are gallons per hour. Okay, let's go ahead and go back and talk points here. For part A, 1 point for the 99. You didn't even have to say net passengers per hour because it gave you the units in the problem. So 1 point for the 99. Part B, 1 point for either one of these standard difference quotients. And 1 point down here for the answer of 132. Part C. Okay, part C has 1 point for mentioning intermediate value theorem. And then another point for talking about P being continuous. So you got a point here for mentioning that it's yes because of the intermediate value theorem, and then 1 point for identifying the continuity piece of the intermediate value theorem. Part D, this was 1 point to come up with the derivative. And you can have it in either form, here or here, either one. And then 1 point for the answer. And again, you don't need gallons per hour on this one because they gave you the units in the problem. I hope that helped explaining what was going on here. Thank you.